Welcome back, students, and let's go to the third problem on tangency. First type of problem, the easiest of the bunch, is the tangent line of a graph of a function. All you have to do is to find out the slope by taking the derivative and plugging in x0 value. Oh, before that we have to find out y0 as well. Anyway, the point I was trying to make is it's easy. Now, this is not that easy because you have to take the derivative implicitly, but if you do some practice how to use these implicit differentiation techniques, it's not too bad because once you take the derivatives implicitly and get this, then all you have to do is plug in numbers and then solve the equation, a linear equation with respect to m. You don't have to do any symbolics here. Here, if you try to find out what y prime is by taking this, breaking up and then solving it symbolically, it's going to take you forever. Not impossible, but I don't recommend it. Plug in the numbers now, and then you get much simpler equation with numerical values. You can do it. Now, what about a vector function? That'll give you a parametric curve. Well, a vector function has two components, x component, y component. In 3D space, a third component, but if you have x, y, z, we have a 3D curve, so it's really difficult to graph, so we don't consider it in Calculus 1. We do it in Calc 3. In two-dimensional space, you're going to get some interesting curve, which I'll show you at the end of this problem set. And we have this vector function, x of t, y of t, and x of t is blue and y of t is red in this problem. And for the tangent line, we have to have a formula here, and we need x0, y0 simply by plugging in t0, pi over 12 here. Not too bad. Plugging in, not too bad. Now the derivative, on the other hand, that can be tricky, and we're going to spend time on that. Once you take the derivative, you have to plug in the value, and you're going to get the slope. Okay, ready to go? All right. Let's go ahead with x0. What is x0? X of t0. Oops. That is cosine squared of 3 times pi over 12. Did I punch in correctly? This one went over here. Okay, this is cosine squared of pi over 4, isn't it? And you can use calculator if you want to, or you can do it symbolically. What is cosine of pi over 4? It's 1 over square root of 2. You can look up the trig table if you want to. Square it, and then you're going to get 1/2. And that's your x0 blue. I can leave the plugging in. I can leave the computation to you for y0, but let's do this. And if you want to try on your own, you can stop this playback and then you can just try it and then you can come back later on. And that is sine cubed of 2 times pi over 12, right? You're plugging in pi over 12. How do I remove this? How do I remove this? Sorry about that. I clicked the wrong key and then, okay, never mind, we got our screen back. Okay, just plug in pi over 12. And then what is this? Sine cubed of pi over 6. And does everybody recall what sine of pi over 6 is? There you go. Pi over 6 is 30 degrees, so sine of 30 degrees is 1/2. Take the third power, you're going to get 1/8. Okay, that's right. So we got x0, y0. Therefore, we are looking for this. X minus 1/2 plus 1/8. That's my tangent line. Blue, red, and then green. Okay, blue, red we are done, and the green quantity, the slope, is something you have to find out. Okay, the slope formula is y prime over x prime. So let's go ahead and find out the derivative. Let's see, the numerator is y, so let's do y first. So this is my function, right? And let's see, reminder, we are doing red, y. So let's take the derivative of this. And haven't you seen this before? You have. Right here, we have this function, and then that function, and those are being recycled here. So all you have to do is go back to this problem and get those derivatives. But let's assume you forgot about everything, and then let's redo it from the scratch. Let's take the derivative of the sine cubed. Here we go. What's the most outside function? It's a sine function. No, it's not. The outermost function is a power function, third power function. So that has to be taken care of first. So 3 comes out as coefficient, subtracting 1 from the power. And then we have to multiply the derivative of the inside. And what's inside here? Sine of 2t. And then we have to multiply the derivative of the sine function. Okay, now let's take the derivative of the sine of 2t. We have to use chain rule. What's the derivative of the outer function? Outer function is sine, so what's the derivative of sine? It's cosine. Oops, wrong key. And then what's the inside? Inside never changes, and I have to multiply the derivative of the inside. What's the derivative of 2t? And that completes the derivative computation. All that you have to do is to simplify a little bit. 3 times 2, so it's 6 sine squared of 2t times cosine of 2t. Okay, all right. So what's m? M is gonna be, you have to plug in t0, this one. So this computation you just did, and you have to plug in t equals to pi over 12. And let's see, what do you have? 2 pi over 12, so it's gonna be pi over 6, and then pi over 6. Let's see, what is sine of pi over 6? Sine of pi over 6 is 1/2. That thing squared. And what is cosine of pi over 6? So what is this? I don't like the way it is written. Let's write like this. And then as for 2 pi over 12, come on, that's just too simple. Let's just go directly to pi over 6. And then as for this, let me see. We have the denominator 4, 2, and that's 3 cancel out. Square root of 3 over 4. I think that's what you're getting. No, I'm forgetting 3. Okay, I guess that's what you're getting. 3 times 2, 2 cancel out here, and 2 squared. Okay, that's correct. Please check. Alright, y prime t squared t naught over x prime t naught, numerator is set. Now let's go over to derivative of the denominator, blue function. Okay. Alright, let's take the derivative of cosine squared. Outermost function is not cosine, it's second power function. So 2, and then inside never changes. Times, what's the derivative of the inside? Derivative of cosine is negative sign and multiply by the derivative of 3t, the inside function, and that completed the problem. So we get negative 6 cosine of 3t times sine of, looks like that's what I'm getting. Did I get this right? Okay, alright. And then let's find out x prime of t0. As a matter of fact, wait a minute, I have a mistake here. This is not m. Y prime of t naught. Y prime of t is a derivative. Y prime of t naught, we are just punching in the value. Okay, alright. Let's see, let's plug in pi over 12 here. So let's see, what do you get? So this is pi over 12, and this is times pi over 12, but 3 pi over 12, what is it? Pi over 4. And 3 pi over 12, that's pi over 4. We have seen pi over 4 before, you see. And let's complete this computation. Negative 6 times, what is cosine of pi over 4? 1 over square root of 2, or equivalently square root of 2 over 2. Sine of pi over 4, again the same thing. And what is this? Square root of 2 times another square root of 2, so it's 2, so it's negative 3. Okay, 6 divided by 2, so yeah, that's right. And finally, I'm ready. The slope is y prime of t0 over x prime of t0 and that is 3 square root of 3 over 4 is the numerator, and negative 3 is the denominator. I'd better increase the font a little bit. Okay, and then after simplification, I'm getting negative square root of 3 over 4. And that completes the slope computation. By the way, this came from that computation over there. And this denominator came from this computation down there. So let me use the color coding to show you what came from where. Finally, let's write down the final answer. Y equals to this slope, x minus 1/2 plus 1/8. Green, blue, red you just did. I guess here we go. Entire problem in the same viewing window. Oh, it was a long problem, but let's have a bit of a recap. Okay, this is a parametric curve. We have a pair of two functions, so it's a vector function. You don't have to know the vectors. If you don't, just consider it as just pair of two functions. If you do know vectors, which I expect you to tell the truth, in that case, yes, it's a vector function, x part, y part. How do you take the derivative? Simply by taking the derivative of x and derivative of y. If you have one more component, derivative of z as well, that's what happens in 3D space. We are looking for slope of tangent line, m equals to y prime of t0 over x prime of t0. To do that, we need a derivative computation, y prime over x prime, and then plug in the value. If you do it right, 3 squared to 3 over 4 over -3, so you end up with this computation. You may use calculator to get simple value if you prefer, so it's computation intensive, I understand, but it's not really outrageous. As for getting x0 and y0, they are just simple plugging in, so no problem there. As a matter of fact, most students handle this part without too much trouble. The derivative part was of course harder, and of course, if you made a mistake in the previous problem, you can't really go ahead here. Because I already took off points for a previous problem, I'm talking about this problem. If I saw any kind of consistency, I didn't doubly penalize students. Whatever the slope, I just gave credit about that one. And as for this part, of course, I did require, and that wasn't too bad. The final expression, slope, x minus x0 plus y0, that form. Well, this is such a long problem that you may end up getting a little bit exhausted. You see, getting everything here and then you have to put them together as a final answer, but you may end up forgetting the final answer here because you just get exhausted and then forgot about what track you were in. And as a matter of fact, that too was one of typical mistakes I had here. Anyway, here's a solution, and I don't need all these now. Let me remove all those because they're all here in the solution in my notebook. A little bit more condensed version, but they are there. And finally, let me show you the picture. So this blue curve is the parametric curve given by that vector function. And then the point 1/2, 1/8 is actually this point here. And then at t equals 0, it goes from here and then goes like this, like that. And then at pi over 12, excuse me, no, t equals 0, it begins from here. And then runs like this, kind of clockwise. Okay. And then at t equals pi over 2, we have this crossing point. But at pi over 12, we have this tangent line because at pi over 12, graph is going from right to left. And then it comes back later at, if I remember correctly, 11 pi over 12. There you're going to get different slope. Anyway, that's the curve, and that's how the parametrics work. Because the parametric part is always difficult, I did expect this problem to be one of the hardest problems, and then it did serve its purpose.